5. So for this one, we're going to set up our u and our dv. And our more complicated part is secant squared. So we have to ask ourselves, what's less complicated? The derivative of secant squared or the antiderivative of secant squared? Antiderivative. Antiderivative of secant squared is just tangent. If we did derivative of secant squared, we get 2 times secant times derivative of secant is secant tangent. We have to use chain rule, which makes it a little more complicated. So secant squared, we're going to put that as part of our dv, because the antiderivative of that is less complicated than the derivative of that, which leaves us with just x for u. So du is going to be just 1 dx. V, antiderivative of secant squared, is tangent of x. So now we've got all our parts, we can go ahead and set this up. We're going to be equal to u times v minus antiderivative of v du. So we get x times tangent of x minus antiderivative of tangent of x dx. So this antiderivative we can do without any u substitution or integration by parts. Right, this is one we need to remember from not too long ago. Antiderivative of tangent is natural log of absolute value of secant of x. Or, remember, this is one where there are 2 options. It could be negative natural log of cosine, absolute value of cosine. So we can make this plus natural log of cosine of x plus c.